Hello everyone, welcome back to this beautiful week once again, and I wish you all a happy Ganesh Chaturthi. And today, let us discuss a few more problems as we are left with the last three problems from our NCRT textbook. Okay, so moving on with the question number 15. Problems on light. Problems means numericals. Fifteenth one. An object of size 7 centimeter is placed at 27 centimeter in front of a concave mirror of focal length 18 centimeter at what distance from the mirror should a screen be placed so that a sharp focused image can be obtained find the size and the nature of the image. Okay, so what is the question? He says an object of size 7 centimeter is placed at 27 centimeter. So to understand this question, first is we have to understand this question, that is an object of size 7 centimeter. So as and when he says an object of size 7 centimeter, consider this as one sentence. What does it say? It says an object of size 7 centimeter. Okay, so now what is our next work? We have to fetch the given data. We have to collect the given data. So the solution. So what is the given data? Object size, that means H subscript O is equal to 7 centimeter. So object size is height of the object. Okay, don't confuse with the object distance or distance of the object. It is an object of size, means uska size, uska height. Okay, that is 7 centimeter. So size may be height, diameter, width, anything. Okay, so HO is equal to 7 centimeter placed at 27 centimeter in front of a concave mirror. So our mirror is concave mirror and it is placed at a distance of 27 centimeter. This is going to be the object distance. U is equal to minus 27 centimeter. And we know that the object distance, we are going to place the object no matter whether it is a lens or a mirror we will be placing the object onto the left hand side, due to which you have to take negative sign. You have to consider negative sign. The sign convention for the object is always negative. So object distance u is equal to minus 27 centimeter. Next, he says of focal length 18 centimeter. Focal length, that is denoted by small f, lowercase f, focal length 18 centimeter. 18 centimeter. Since this is the concave mirror, the focal length of the concave mirror is in negative. It holds negative sign convention. So focal length will be minus 18 centimeter. Okay. Next, at what distance from the mirror should a screen be placed? Okay. Where we are going to obtain an image? We are going to obtain an image on the screen, right? We are going to obtain the image on the screen. So this will be, what is he asking? He's asking the image distance, which means where the image is going to be formed, at what distance the image is going to be formed. So that a sharp focused image can be obtained, find the size and nature of the image. Size of the image is hi is what? We know the focal length. We make the predictions also. How will you make, focal length? Roughly you can draw here. Okay. Roughly what you can do, you can just take this one. This has origin, and we know it is, the object is placed on left hand side. So this is 18, then 18 twos are 36. So where is the object placed? Between, this would be F and this would be C. So object is placed in between F and C. And where the object, where is the image that is going to be formed? The image is going to be formed behind C, right? The image will be formed behind C. It will be inverted, that is real and inverted. And the image size would be magnified. Why? Because the object is closer to the mirror. So you will be getting the image enlarged. Okay. So now let us see now. What we have concluded, that the nature is real, right? And the size is magnified. Okay. I'll write it as magnified or enlarged, you can say. Let us consider, let us see now. So first thing, after writing all the given data, once you write all the given data, what is the next procedure? That you have to go with formula. So we know the mirror formula, 1 by F is equal to 1 by V plus 1 by U. Now substitute the values. F is minus 18, 1 by minus 18 is equal to, image distance is what we have to find out. So write as it is, plus, what is the object distance? It is minus 27, right? 1 by minus 27. Put it in a bracket because we are getting simultaneously two signs. Now, 1 by minus 18 is equal to 1 by V plus into minus is minus 1 by 27. Now, transfer this minus 1 by 27 onto the LHS. It becomes minus 1 by 18 plus 1 by 27 is equal to 1 by V. Now take the LCM. LCM is 18, 27. Now, what we will do here? 9 2s are 18, 9 3s are 27. 9 2s are 18. So 2 1s are 2, 3 as it is, 3 1s are 3. So if you multiply these, 9 2s are 18, 18 3s are 54. So 54 is our LCM. 54 is our LCM. So now right here, 54 is our LCM. So how much you have to multiply? So 9 2s are 18, is left with 3. So 18 3s are is 54. 27, 9 3s are 27. So left is 2. So 27 twos are 54. Now write minus as it is. 3 ones are 3 plus 2 ones are 2 is equal to 1 by V, which will be equal to minus 3 plus 2. So one has got plus sign and the other term has got minus sign. So whenever you get 1 plus and 1, that is one positive integer and one negative integer, then you have to subtract. So 3 minus 2 is how much? 1. And the bigger number sign. Okay, here the bigger number is 3 and the sign of 3 is minus. So write minus 1 by 54. Okay, so now therefore reciprocal. Therefore V, reciprocal of 1 by V is 54 by 1. That is minus 54 centimeter. Make sure when you are taking the reciprocal, the sign will not change. Only the numbers will interchange. From the denominator, it will shift to the numerator, and from numerator, it will shift to the denominator. But the sign remains same. So V is equal to minus 54 centimeter. We have made some assumptions, right? Predictions rather. What was our image? The nature of the image was real. So negative sign we have got the negative sign. The image distance is negative, which says that it is real image. Okay, real and inverted, right? Inverted, once we get the image, height of the image, then we'll find it whether it is inverted or what. Okay. So now next we have to find out. Next we have to find out the, this is over, height of the image. So we know magnification formula, that is M is equal to minus V by U, which will be equal to HI by HO. Okay. So the linear magnification is, we can call it as linear. In exam they may you would be asked to write the definition of a magnification. So what you will write? The ratio of height of the image to the height of the object is called as linear magnification. Is that clear? So now substitute the values. We know what is the value of V, which we have found out now. Write minus as it is. So minus 54 is the V value. And what is the object distance? It is minus 27 is equal to height of the image is what we have to find out, and height of the object we know it is 7 centimeter. Now cross multiply. Before cross multiplication, let us simplify these signs. Minus into minus is plus 54 divided by minus 27, and I'll multiply, cross multiply 7 here. It becomes into 7 is equal to HI. So now 27 ones are 27, 27 twos are 54. So plus divided by minus is minus, 7 into 2 is 14 is equal to HI. So therefore height of the image or size of the image you can say is minus 14 centimeter. Now you can see that the image was real and inverted. We said the nature of the image is real because it holds minus sign, and it is inverted because size of the image or height of the image we got in negative. So it shows this negative sign indicates that the image is inverted. Okay, and the height of the image is 14 centimeter. You could see the height of the object is 7 centimeter. It is almost double, that is enlarged. We have got magnified image. Is that clear? So what was asked? What distance from the mirror should a screen be placed so that a sharp focused image can be obtained? So the object, so what distance the screen has to be placed? The screen has to be placed at a distance of 54 centimeter. Okay, the screen has to be placed at a distance of 54 centimeter. Okay, so this you have to write. And then what has he asked? Find the size of the image. A size of the image is 14 centimeter. You have to write And then nature, since the image distance is negative, the nature of the image is real. Is that clear? I hope this is clear to you all. So these all you have to write it in your classwork, physics classwork. So we'll move on with the next, this one. So what you have to do is you have to practice this problem so that you will be familiar with how to use the sign conventions, and also you will be thorough. Once you read the question without solving, you will be able to find the answers. No matter it is not exact values, but yes, you can make some predictions that you would be getting the real and inverted image or magnified image. Because the only thing is like we have 6 things, okay, 6 positions that we have. Those 6 cases only we have to study. And we have 2 more problems from the NCERT. Then hopefully tomorrow we will move with hot questions. Yeah. What are hot questions? Am I going to prepare the questions keeping on in the woven income? Are they going to give us heat energy? Yes, somewhere it is going to make you think high order or higher order thinking, where you require higher order thinking. So we call them as hot questions, right? Okay, children, we'll move on to the next question, that is 16th question. Find the focal length. Find the focal length. Find the focal length of a lens of power minus 2D. What type of lens is this? Okay. So what is asked here? Find the focal length. Find the focal length of a lens of power minus 2D. Power P is given as minus 2D. And in lens we have concave lens and the other one is convex lens. And convex lens is the converging lens. Convex lens is the converging lens and concave is the diverging lens. Since convex lens is converging, the focal length would be positive, and here concave is diverging, so you will get the focal length, that is the refracted rays would be meeting on the left hand side, so the focal length here is negative. Is that clear? So now what type of lens is this? Just by the sign you can write. So which sign? Minus 2D. The power is minus 2D, so we have diverging lens, that is concave lens is being used. Okay. Now he's asking to find the focal length f. So we know the formula for the power, that is reciprocal of focal length is the power. So 1 by f. Okay. So now substitute the power, that is 2d. D means diopter. So minus 2 is equal to 1 by f. Minus 2 is equal to 1 by f. So therefore, f is equal to 1 by minus 2. That is equal to 0.5. Shall I write? 0.5 minus 0.5 meter, because diopter is per meter, right? 1 per meter is equal to 1 diopter. So when you take the reciprocal here, so this per meter will become meter. So focal length is in meter. Is that clear? Now, if you want to convert this into centimeters, you already know 1 meter is equal to 100 centimeter. So now 0.5 meter is equal to how many? So here the meter is the bigger value, the larger value. You are converting that into smaller value. So what you have to do, whenever you are converting the larger unit into smaller unit, you have to multiply. And if you are converting the smaller unit into the bigger unit, you have to divide. Okay. What you have to divide? If they are meter and centimeter, we know 1 meter is equal to 100 centimeter. So since meter is the larger value or higher value, okay, so what we will do, we will multiply this with 100. So minus as it is. So 0.5 into 100 is 50 centimeter. So the focal length is minus 50 centimeter. So since the focal length is minus 50 centimeter, so what kind of lens we are going to use? We are going to use concave lens. We are going to use concave lens, that is diverging lens, which will have a negative focal length or a focal length with negative sign convention. Is that clear? So what have we done here? We have just fetched the data first, and then we have taken the appropriate formula for that, and then we have substituted the values, and we got the answer, right? And based on the sign convention, we have decided whether it is a concave lens or a convex lens. Is that clear? Yes? So this you have to remember. So per meter is equal to 1 diopter. So here, when you take the reciprocal, okay, you'll get focal length in meters. To convert these meters into centimeters, you'll be multiplying by 100, because 1 meter is equal to 100 centimeter. Is that clear? So we got minus 50 centimeter is our focal length. So the focal length of a lens of power minus 2D is minus 50 centimeter, you can say. And the type of lens that we use here is concave lens. Okay. Hope it is clear. And based on this focal length only, your lenses, the spectacles that you wear, okay, these lenses, the applications, if they ask, the applications of the lens would be in the spectacles as well. If you have a good power, then you will be able to see better. If the power decreases, then you'll be suffering from one or the other defect. Okay, moving on to the next question, that is 17th question. A doctor, okay, we got question now. A doctor has prescribed a corrective lens of power plus 1.5D. And I'm very sure that you have already found what kind of lens is used here. Find the focal length. Most of them might have given an answer also. So kudos and congratulations to those who have given the right answer. What is the right answer, sir? That when I reveal, then you can tap yourself. Isn't it? Yeah. Is the prescribed lens diverging or converging? Hope the explanation of the last question would help you here, right? Because he did not ask whether this is a concave lens or a convex lens. He has just twisted the question and asked whether it is diverging or converging lens. And also you have to relate this. So magnifying lens, okay, what is, for which one we call magnifying lens? Which is going to magnify. So how will you say whether it is, which is going to converge? We call that only as magnifying. Diverging, it will make the image smaller. So diverging lens, we don't call it as a magnifying lens or a magnifying glass. So you should be very clear with that. So when you are going to magnify the image, when you want to see the magnified image, you will be using converging lens only or converging mirror only. Clear? So whenever they ask, you should be very thorough with this one. Suppose if they ask you a question, because they may not ask you direct question, they may ask, if at all I want to read the letters from the newspaper, which I cannot see, so what lens I would be using? So you should understand, okay, he has to read the letters because he cannot see the letters which are in very small size. So he wants to magnify the size. So which lens he has to use, which magnifying glass he has to use, which glass he has to use? The converging lens. So what is that converging lens? That is convex lens. Yes, he has to use the convex lens, okay, the magnifying glass which is made of convex lens, so that he can read the letters easily. Okay, in the even like they may say the palmist or an astrologer, to read your palm he is going to use the lens, or what kind of lens is he going to use? So again, to read your, because he has to see the lines of your palm very clearly. So when they are magnified, he can read it properly. So here also he is going to use the magnifying glass. So that is convex lens. Okay. So now let us solve this one. A doctor has prescribed a corrective lens of power plus 1.5D. Power P is equal to 1.5D. That is plus. If nothing is written, it is understood, it is positive. Okay. Find the focal length of the lens. Find the focal length of the lens and also tell whether diverging or converging lens is prescribed to him. Okay. So now, so what is here? P, power is equal to 1.5D. Okay. Now let us see the focal length. First, let us find out the focal length. Okay. So now power P is equal to formula. We have 1 by F. Now substitute the value of F. That is 1 by 1.5. Okay. So now, sorry. I'm so sorry. Okay. So power is equal to 1.5. Okay. So now, so if I have to write it as, I'll write it as per meter. Okay. Per meter means 1 by m. Okay. So when I take the reciprocal, okay. So when you, what will happen if you cross multiply? F is equal to 1 by 1.5 per meter. So when this will go up, if you take this per meter in the numerator, it will become meter. Now 1 by 1.5 you have got. So what you will write it as? I'll write it as is equal to 10 by 15. I will write meters. 10 by 15 meters. Now convert that into centimeters. I'll multiply it by 100. So that will be equal to 10 into 100 by 15. So 5 3s are 15, 5 20s are 3 1s are 3 3s are 9, then 0.33s are 9. So how much it would be? It would be 20. So 23 is 60, 23 is 60, 66. So 66 centimeter. 66 centimeter. So the focal length should be of 66 centimeter and a positive. Positive means it is convex lens. Okay. So because the convex lens has a positive focal length, so the focal length of the lens is 66 centimeter and the prescribed lens is diverging or converging. It is converging. It is converging lens. Is that clear? So here in the previous question, diverging was used, that is concave lens, and here we are using the converging lens, that is convex lens. Is that clear? Because why we are using the convex lens or why we are going to use converging? Because we got focal length in positive. So the lens prescribed would be positive. Is that clear? Hope even this is clear. So copy all these question and answers in your classworks and try to solve as many as questions that you can. Even you can frame your own questions. You can frame your own questions and you can solve. Okay, we will try to solve the one last problem. That is, actually we thought of starting tomorrow, but we will do it today itself. 18th problem. A bright object 50 mm high stands on the axis of a concave mirror of focal length 100 mm. 100 mm is 100 millimeter, and at a distance of 300 mm from the concave mirror. How big will the image be? How big will the image be? Okay, so it is asked that a bright object 50 mm high. High means again it is height, that is size, right? So object size is HO is equal to 50 mm. Okay, stands on the axis of a concave mirror of focal length 100 mm. So here the focal length of the concave mirror, he says that stands on the axis of a concave mirror. That is principal axis is saying. Concave mirror of focal length 100 mm. Focal length 100 mm. So it is given that focal length f is equal to 100 mm. And since it is a concave mirror, it will have a minus sign, right? Next, at a distance of 300 mm. So what is he saying here? And at a distance of 300 mm from the concave mirror. What is that? This bright object. This bright object is at a distance of 300 mm from the concave mirror, which says that is the object distance u is equal to minus 300 mm. And he's asking how big will the image be? He's asking to find out the image height of the image, that is hi. You have to find out height of the image. So to solve, first write the formula 1 by f is equal to 1 by v plus 1 by u. Now f is how much? Minus 100. Image we don't know. Okay, why we are going to find out the image? Why? Because once we get the image, then only we can use the magnification formula and then we can calculate the height of the image. Plus 1 by u is minus 300. Put it in a bracket. Now minus 1 by 100 is equal to 1 by v. Plus into minus is minus 1 by 300. Now shift this onto the LHS. So minus 1 by 100 is plus 1 by 300 is equal to 1 by v. Is that clear? So minus 1 by 100 plus 1 by 300. Now take the LCM. LCM would be 300. Yes. So LCM is, I'll take it as 300. Okay. So now how much it would be? Multiply here with 3 and here with 1. So minus 3 ones are 3 plus 1 ones are 1 is equal to 1 by v. Now again we have one positive integer and a negative integer. What we have to do? We have to subtract. So subtract, we'll get 3 minus 1 is 2. Bigger number is 3. It holds minus sign, right? Minus by 300. So therefore, v is equal to reciprocal of this one minus 300 by 2. So how much you get? 2 ones are 2, 150s are 300. So image distance is minus 150. See, don't write centimeter or meter. What is given here? They have given in millimeters, right? Millimeters. So image distance is minus 150 millimeters. Now using this v is equal to minus 150 mm, we'll find out the height of the object. So now we know magnification formula, m is equal to minus v by u, okay, and that in turn will be equal to height of the image, that is ratio of height of the image to the height of the object. Now substitute the values. You know v is minus 150 by u is minus 300. Put it in a bracket. Height of the image you don't know. Height of the object. Height of the object is 50 mm. Clear? Now cross multiply. I will do it here. So cross multiply now. Before that, minus sign and minus sign will cancel. So you are left with minus sign. So minus 150 into 50 by 300 is equal to hi. So 10 10 will cancel. 10 10 will cancel here. 3 ones are 3, 5s are 15. So minus 25 mm is equal to hi. So height of the image is 25 mm. So what is asked? How big will the image be? So it is 25 mm. The image will be 25 mm. Yes. So it is decreased, right? Focal length is 100. Object is 300. Okay. So 100 to 100, that is beyond C. Obviously, you will be getting the diminished image, right? So No matter you have got real and inverted, because the minus sign says it is real and inverted, and 25 centimeter, that is below the principal axis. So here you have got a diminished image because the object is placed beyond C, that is center of curvature. We have focal length 100, then center of curvature is 200. The object is placed beyond C, so you will get diminished image. Hope this is clear to you all. We'll meet tomorrow with few more questions which are of higher order thinking. So be prepared, and today we will meet in the doubt clarification class at sharp 5. So if you are going to be late, I'll be locking and you'll not get entry into the class. So if it is asked you people to come on sharp 5, you have to be there on 5 at 5 o'clock. If you're going to delay, then don't text me later on like, please unlock sir, unlock, I want to join. If you want to join, then definitely will not delay, right? Will not be late. You will be on time. If you miss this YouTube live class, at least you can leave later on. But doubt clarification, you have no chance to. Okay. So thank you so much. You all have a great day. Thank you.